So good afternoon all. Welcome to the eRobotics Telerobotics topic group seminar. Please note that this event will be recorded and will be available to watch later at the eRobotics portal. Please keep your microphones muted during the seminar and raise your hand if you want to ask questions during Q&A, or just type your questions in the chat during the webinar. My name is Karol Janik. I'm Robotics and Automation Technology Manager at the MTC Manufacturing Technology Center, and I'm co-chair of this topic group with my much more capable colleagues, Alois Matheson from CERN and Daniel Leidner from DLR. So the topic group is open for everybody, not only eRobotics members, but some of the activities in the future will be reserved only to eRobotics members. And if you're not a member, I highly encourage you to have a look at the main eRobotics website and details on the membership, because it's really being worth part of this community. I will put some of the most important links and contact details to the chairs of this group in the chat in a second. So today we have quite packed agenda. We'll hear two really interesting keynotes from Chang Liu from Extend Robotics and from Alireza Rastengraf from the University of Birmingham. We'll follow this up with some general topic group updates, an overview of the future activities, and we'll kick off first of the series of road mapping sessions at the last half an hour of this event. So let's start with our first keynote. You will hear from the founder of Extend Robotics, Chang Liu. It will be a 15-minute presentation followed by 5 minutes questions from the audience. So Chang, I'll hand over to you. You're free to share your screen. And yeah, looking forward to your presentation.
Sounds good. Sounds good. Thank you so much, Karol, for the introduction. And really great to be here. Let me start with sharing my slide. Can you see my slides?
Yeah.
Awesome. All right, let's get started. So hello, my name is Chang. I'm the CEO and chief designer of Extend Robotics. We built robotic software to extend the use of robots at scale to ultimately enable remote physical workforce through metaverse, robotics, and AI. So this video shows an operator controlling a robotic arm pouring a pint of beer. He's using a virtual reality interface, running our proprietary software. So you've probably seen this live demonstrations on BBC Dragon's Den stage earlier last year. Yeah. So the software we use already available to download from Meta and Steam application stores since last year. And yeah, feel free to jump in and give it a go. So, quite different from most robotic companies, our vision is to extend human capabilities beyond physical presence instead of replacing people, to ultimately scale the labor capacities around the globe. So that's why we developed this immersive human-robot interface software with extended reality technologies to enable non-robotic experts to intuitively operate robots remotely. Yeah. So prior to Extend, I was a postdoc at Imperial College and spent 10 years in robotics and AI research and in high-tech startups. So I started the company in 2019 and brought together a strong technical team with expert experience in robotics, immersive technology, and cloud computing. So this team is well established with background from Imperial College, National Nuclear Robot Research Centers, Tata Consultings, and AWS. We recently collaboration with Universal Robots and RAR UK Automations as one of the largest collaborative robot distributors. Sounds great. Let's story starts from here. So the concept of teleoperated robots is nothing new. It was invented 50 years ago. I'm sure a lot of everyone in the audience is very familiar. It's mainly for surgeries, nuclear, space, and military applications. The idea is simple, is to allow skilled operators to remotely perform hard-to-automate physical tasks that are mission critical. Really, but the question is why we have spent such a long time developing these technologies, but still not able to adopt in a wider market beyond these extreme environments? Well, I believe the answer is really that today's robotic control interface really sets a large barrier for people to utilize them, to use them easily. So their interface are custom equipment based on physical joysticks and lots of flat 2D screens. So therefore, they're typically expensive, hard to use. So they require highly trained professionals to operate them, but still result in slow operations and stressful workload. And our solution addresses these shortcomings and expands potential of the market. So we have created a gamified human-robot interface middleware platform based on extended reality technologies, meaning VR, AR, or mixed reality. But we focus on creating the most advanced 3D graphics and streaming engine that has been patented. Fundamentally, it offers an ordinary user an intuitive approach into a remote workspace, enabling the use of affordable consumer VR equipment as a standardized interface to operate a wide range of third-party commercial robots. So this really is a software-focused solution that acting as an easy upgrade to existing third-party robots. It consists of two parts. First is the Extend AMAS VR application that's running on a consumer VR equipment as an ordinary VR games. And the second part is the peripheral hardware we call SenseKit and RoboKit, which can be attached to these robots, enabling 3D sensing, connectivities, and control. So both parts communicate over any networks to enable remote operations. And yeah, so our patented volumetric streaming algorithm really gives us outstanding latency performance and 20 times bandwidth reduction compared to state-of-the-art streaming techniques. So bear in mind, this is really streaming the 3D volumetric data rather than a traditional 2D video. So yeah, so that part is really outstanding. So we're fortunate to be in a quite unique position in the market where our core technology combines outstanding 3D visual perceptions with intuitive control, and this results in an order of magnitude more productive solutions with lower cost of ownership compared to any alternatives in the market. The benefits is really to remove the barrier for people to use robots by reducing the interface hardware costs from typically over 100,000 to just 300 pounds of gaming VR headset, reducing the setup and the operator training time from days, weeks to just a few minutes, and 3 times faster manipulations with reduced cognitive workload. And our integrated automation feature is more robust and more efficient with human in the loop. Particularly, it features 3 key technologies. First is the volumetric telepresence, which renders this remote workspace around the robot in realistic, colorful 3D with audio in low latency. So providing operator with critical real-time depth perceptions and flexible viewing angles at the first column here, while have the ability to fuse multiple 3D cameras in the same scene. And the second is this interactive digital twin that provides intuitive user gesture input at high degree of freedom with haptic to control multiple robots. So the middle video here shows an example of operation of 8 degree of freedom robots with a mobile base being controlled with 3 interactive targets. Yeah, as a typical Tiago robots. The third part is the automation copilots that allows the operator to rapidly automate any physical tasks remotely on demand within the same interface. So this feature enables remote supervision, intervention, and reprogramming of automated pipeline, while being compatible with third-party automations via standard ROS interface. Yeah. So our vision is really to combine these three key features, technologies will enable large-scale fleet learning over the clouds via shared autonomy, ultimately delivering robust real-world value in day one with human in the loop, while accelerating automation by learning from human intelligence. And this is really our vision. So aiming to have this automation copilots to start with repeating simple tasks and ultimately learning to operate more general purpose generic dynamic tasks over time and more and more capable, and hopefully we can allow less operator to control more robots, and that's the method we kind of scales the labor capacity as we originally stated our mission statement. Yeah, so that's the technology, and then a little bit about the commercial side. So with the large global market for telerobotics at 82 billion by 2027, our solution enables general purpose remote working, extending beyond traditional telerobotics applications. So despite the traditional value for hazardous environments on the left to liberate people from dangerous tasks, such as nuclear decommissioning, utility inspections and maintenance, and even the space applications, the new productivity value we can unlock on the right side is to facilitate this remote access to global labor and expertise and accelerate adoption of robotics in high variability tasks in manufacturing, logistics, agriculture, and even general service. So our market entry, so we typically set up three key offers for our customers. First is our core offer is the OEM software, offering recurring license fees to technology integrators and research projects who are already using their own robots. And second is the integrated system that combines one-off hardware payment with recurring license fees. This drives the adoption of new application users who don't yet have their own robots. And third, for the case of tailored customizations, we'll offer professional service to support our visionary customers to fit for their specific use case. So far, we have established world-class channels and partners accelerating our route to market. So we're partnered with the UK's largest robot distributor, RAR UK Automation, and distributing our app through mainstream VR application stores, as mentioned. And second, we have been certified and partnering with the world's largest collaborative robot vendor, Universal Robots, as well as UFactory, Mitsubishi Electric, and Power Robotics. And third is our strong connection with management consultings and integrators will hopefully integrate the technology into enterprise and end users, and potentially, hopefully we're encouraging everyone to try to resell our product as well. And any partnership collaborations, we're really keen to work and try to put most of our time to support our partners to integrate our technology better into their solutions. So I've also prepared a few examples, use cases. One example is the nuclear use case for remote handling of contaminated materials in Alpha Glove Box. So we've been working with Atkin, one of UK's largest technology integrators for Sellafield, who has purchased our software and peripheral hardwares for their robotized glove box projects. And this project will make it much safer and more efficient for glove box operations by removing human exposure to radiation risks. A second example is the space application. So we focus on in-orbit servicing and manufacturing applications. We've conducted quite a few feasibility studies funded by UKSA and European Space Agency. And the solution has been purchased by Satellite Applications Catapult. So we aim to develop this safer and faster operation to allow astronauts to perform complex handling tasks within spacecraft, and even allow subject matter experts from Earth to perform assembly and servicing tasks in the space. Yeah. The last but not least is the third use case is the precision viticulture. So we've led a consortium which consists of Queen Mary University's Saffron Grange vineyard in Cambridge to collaboratively develop this integrated human augmented robotic and intelligent sensing platform to revolutionize the grape harvesting and pruning. So this is a 1 million project awarded by Innovate UK. Yeah, so we'll be working on that as well. Yeah, so that's pretty much it. I think it's about 15 minutes. Yeah, so thank you so much for listening, and any questions would be great.
Thank you very much, Chang. Very interesting. Yeah, if there are any questions, just feel free to ask or drop them in the chat. The one question that I have, yeah, agri-tech is quite interesting in terms of telerobotics. Do you see much uptake in that space, more from, let's say, end user perspective rather than research and development? Because the agri-tech with robotics is obviously tricky with having the right business case for deploying, complex solutions. It'd be interesting to hear your perspective on that.
Yeah, that's a great question, Carl. Yeah, so for the agriculture, we have been engaging with quite a few farms in the UK. They responded quite positive. I think right now, I think there's a strong need, especially with the labor shortage in UK, with the kind of returning European farmers. There seems to be a quite big problem in labor availabilities in UK, especially for harvesting and type of pruning. That is labor intensive, but also time sensitive, and especially during that period of time, really need to have enough people to do the harvesting. So I think there's a strong need to have some kind of solutions to bridge the labor shortage. I think most of the concern from the farmers is that the readiness of technology to actually deliver the promise, and the robustness of system and speed of operations, and having this teleoperation as a baseline for remote operations, at least having someone far away, even in a different country, to remotely operate robots to do prunings or harvesting is a great starting point, and the fact that having having human in the loop greatly enhance the robustness of the system, so that is also having strong reliability to make sure the operations continues even without supervision. So that is quite a strong selling point for the customers, but also the value of multi-purpose setup where you can have one system that could be used for many operations. It is quite a good selling point.
Yeah, interesting. Yeah, we have a couple of other questions. There is one in the chat. what is your view on humanoid hands or grippers for tasks, and where do you see haptic feedback as a limitation to operator immersion?
Sure. So that's really two questions. Well, for the end effectors, I think yeah. So definitely having human-like hand is I guess typically is two directions that people can debating. One is having human hand that is generic end effectors and be able to use different human tools. The second option is to have kind of swappable end effectors, custom end effectors, but you can switch different end effectors. And I guess both are good options. It's really depending on the applications. If there's already a lot of human tools out there for the application that already have a lot of human tools out there, it's probably cheaper to have a hand and just be able to reuse the human tools. But if there are the applications where tools are not that available, yeah, the other way around. Yeah, but I think particularly for teleoperation, it's definitely a good bet on a human hand, where you because you're expecting someone behind the robots to operate them. So yeah, and we are working on hand trackings and be able to have next stages to have the compatibility with a few robot hand, so that it would be much more dexterous operations. And regarding the force feedbacks, yes, I mean it definitely helps on the accuracy when the visual feedback is limited. What we found is that most of the operations, if you have a very clear visual feedbacks, and especially with 3D interface, it gives you a quite immersive and direct representation of the position orientation. It turns out you can do quite a lot of things with simply visual, but having haptics just as a cue of indicating touching something is quite useful on top of that. So yeah, so we definitely look into. I think our goal is also to try to build this as more complete perception as possible within the commercially available scalable hardware interface, because ultimately we want to make sure our solution is could be adopted by wider market, and exploring how haptics or alternative sensories could be integrated into commercial hardwares is definitely our key objectives here.
Thank you very much, Chang. There is quite a few other questions, but we need to crack on with the second keynote. So if you could answer in the chat, or others, if you could post your other questions in the chat, and Chang will hopefully try to answer them, that would be great.
My email is in there as well, so feel free to drop me a line.
Yeah, brilliant. Thank you very much. And our second keynote will be Dr. Ali Reza Rastingraf from University of Birmingham Extreme Robotics Lab. Hi, Ali. Again, it will be 15-minute presentation and 5 minutes for questions and answers, and then hopefully much more time for questions in the chat and maybe follow up after the session. So, Ali, the floor is yours.
Thank you very much, Carol. Let me share my screen. Do you have my screen now?
Yeah.
Brilliant. Hello, everyone. My name is Ali Reza Rastingraf. Before starting my presentation, I want to thank the Manufacturing Technology Center and Carol, Daniel, and other colleagues for organizing this fantastic seminar. About myself, currently I wear a few hats. I'm a senior robotic scientist at the Faraday Institution, focusing on robotizing the process of disassembly of EV batteries for reuse and recycling. And in addition, I'm co-founder of National Sustainable Robotics Center, which is especially designed for robotic disassembly. And at the University of Birmingham, I'm co-founder of Extreme Robotics Lab. One of the newest and best equipped robotics research facilities is a 1,000 square meter custom designed campus lab. You may not have heard of our lab because we were awful in advertising ourselves, and only very recently we launched our website. Anyway, let's talk about telerobotics. So you know that robotic telemanipulation significantly facilitates the execution of various challenging tasks across multiple domains by amplifying human manipulation capabilities in remote and safety critical environments where direct human interaction is basically impractical. For example, in the medical sector, telemanipulation systems are used to perform complex surgical procedures, while in nuclear context, they assist in conducting complex decommissioning tasks. One of the common telerobotic systems that's usually used in nuclear industry is master-slave manipulators. These systems have a master unit, which is operated by a human, and a slave unit, which performs actions in hazardous environments. And movements of the master usually will be mirrored by the slave and is providing actually direct and intuitive control interface. And currently, telemanipulation setups in on a structured environment predominantly depend on the operator's expertise. And managing actually remote manipulation tasks using these mechanical devices in such settings is significantly challenging, and also the operator experiences there's a cognitive load actually on these operators during manipulating these mechanical teleoperation systems. And to illustrate, when picking and placing an object in remote scene, the operator must intelligently calculate the inverse kinematics while avoiding actually these mechanical singularities and navigate the robots towards the desired positions. So we deployed or developed autonomous grasp planner at nuclear facility at National Nuclear Lab in 2016 for sorting and segregation of contaminated nuclear objects. We used 6-stop option as master unit and industrial KR100AT as the slave robot. And our developed telerobotic system combines master-slave teleoperation with a model-free and learning-free grasping algorithm through a dynamic grasp re-ranking strategy and semi-autonomous reach-to-grasp trajectory guidance. So the re-ranking metric dynamically updates stable grasp based on the slave device current state, and also the trajectory guidance systems helps in maintaining the smooth trajectory by controlling haptic forces. In addition, virtual pose controller is integrated with the guidance system to automatically correct the indefective orientation during reaching towards the grasp position. So I will go in details talking about grasp planner in the next slides. This is me in the video back when I was younger in 2017. As you can see, the robots can follow and grasp the moving objects tracked by vision system, and I can hand over the object to the robot during collaborative working that we have. As you can see, this is really autonomous, and there is no man with joystick sitting behind the scene. And while I randomly move the object, a set of likely grasps are evaluated online to generate a feasible grasp with respect to the current configuration of the robot, with respect to the target grasp, and also the constraints of finding a collision-free trajectory to reach that configuration. And we develop a method that dynamically switches between two planners. Local planner, which smoothly tracks the objects and keeps a steady pre-grasp pose, and a global planner, which quickly moves the hand to a new grasp on a totally different part of the object if the previous part becomes unreachable. So this is our grasp planner that I will explain that how we integrated this grasp planner to Telerobotics platforms. But Telerobotics is also a crucial tool in remanufacturing, particularly in the automotive industry and for reuse and recycling of EV batteries, electric vehicle batteries. I'm the co-I of the EU-funded Rebellion project, and also I'm leading the automation part of Relic project, which is funded by the Faraday institutions. And these two projects primarily focus on robotizing the process of testing, disassembly, and sorting EV batteries using advanced robotics and artificial intelligence. So battery disassembly has a hierarchy that starts at the pack level, goes down to the module level, and ends at the cell level. However, the process of robotic disassembly is challenging and carries high safety risks, such as thermal runaway and explosion. This means that temperature immediately rise to 600 degrees Celsius, and even firefighters may abandon a burning vehicle on the road, returning only a few days later to remove this burned vehicle. Other risks include the release of electrolytes and toxic gases, short circuits, and fires, which necessitates actually the use of telerobotics for safe and remote operations. In addition, there is diversity in the design of batteries and a lack of information from manufacturers about these designs. It means any development must be generalizable to be applicable to different battery models and different types of batteries. In addition, there are almost no safety regulations at the moment related to these EV batteries. At the moment, we hear a lot about EV batteries reaching to the end of life. However, we are also facing another serious challenge with the pile of damaged batteries. Sometimes these are only labeled as damaged, but with proper testing, they can be brought back into their life cycles, basically. Sometimes only by replacing a battery module, the entire pack can be retrieved. And I'm working closely with one of the largest insurance companies in the country, which is struggling with increasing number of these kind of damaged batteries. The only solution available at the moment is to send these damaged batteries to the salvage centers for recycling, for direct recycling, and shredding them into small particles to create black mass. And unfortunately, the quality of black mass is not sufficient to manufacture new batteries using these materials. Therefore, there is a significant profit loss for insurance companies, for the end users, primarily due to lack of safe mechanism for testing and disassembling these kind of high-risk batteries. To address this challenge, we have developed various frameworks for the autonomous testing and disassembly of EV batteries. However, we have categorized disassembly tasks into autonomous tasks, such as repetitive actions like unbolting, and semi-autonomous tasks, which are sensitive, like cutting the battery module to remove the cells. And what you see in these videos is a pilot study designed for disassembly and sorting disassembled EV battery components. And as you can see in the first video, the robot autonomously scans the object in a clutter environment to create a 3D CAD model of the objects, which is sometimes only a partial CAD view will be created. It's in a clutter environment. And within this developed framework, the user can manually drive the end effector to the desired position, or the robot can control in a share control mode. And in the variable autonomy mode or share control mode, the developed digital twin assists the user to visualize the pre-planned trajectory suggested by the grasp planner. Once this planner is executed, the user can take control of the robot at any time. However, the grasp planner assists the user in moving the robot along one of the proposed trajectories, and any deviation from this path will be appeared as a resistance on the haptic device. That's why we call it force-guided teleoperation system. We extended upon our previous work by developing 2 additional teleoperation platforms for the application of battery disassembly, but it can be generalized to various applications, disassembly of complex products or any other applications that in the first slide I explained. In the first platform, we use 2 identical 7-degree freedom cobots as master and slave units. And in the second platform, we use a 6-stop Phantom Omni haptic device as the master unit and Franca arm as the slave unit. For the first platform, we implemented joint impedance control, and for the second one, we use only Cartesian impedance control system. And we evaluated these 2 platforms across various disassembly tasks, and we found although the haptic device showed a higher success rate, but using pair cobots, the first platform enhanced the speed and also the consistency in task completion. Also, we found that one-to-one torque mapping, excuse me, the torque mapping actually between the cobots improved grasping and cutting these 2 applications by providing more realistic interaction and stronger tactile feedback. And it is also increased operator efforts and impacted the quality of cut, because actually cutting is an important procedure during disassembly for various stages during disassembly, especially from reaching from module level to the cell level. We need to cut the modules, the battery modules inside the battery pack. And later we enhanced user capabilities by integrating mixed reality technology into the Telerobotics systems. And we developed a gait tracker in which the user wears a VR headset. In this case, we use a Varjo headset. And as you can see, the black dot in the video in the middle of the screen, actually the black dot indicates the gaze with its position being continuously calculated in the camera frame. And we utilized this gaze tracker basically to construct a logical task planner for disassembly. So the gaze tracker serves as a medium to interact with the simulation environment. As you can see, the user uses this gaze tracker to verify whether the capture point cloud includes all points of interest, first of all, and then the segmentation using fast sum will be conducted. And in that sense, actually, the user will select the hierarchy of disassembly tasks just by steering on the objects and marking these objects. And we enhanced a user capability by integrating our mixed reality platform into the master-slave teleoperation system. As you can see, this video on the right-hand side shows the headset view, where the user has access to multiple camera views and can switch between these camera views using virtual buttons, as you can see in the central image. So when the user holds his or her palm in front of the camera views will be activated, and he or she can actually switch between these camera views. And also we use depth images as an interface medium, which will be explained in the next slide. And we found that users exhibit improved performance in terms of time and accuracy when completing tasks, especially contact-rich tasks like cutting, when we are using actually the combination of camera views, point cloud views, and different types of interfaces. So we conducted an experiment controlling the robot in 2 different modes. The first one on the left-hand side is manual mode, and the right-hand side.
Last minute, Ali.
Oh, sorry. Yeah, I will try actually to squeeze on that one. So we performed disassembly for battery using different interfaces, including point clouds and also a direct view of the scene. And we evaluated basically these 2 platforms with each other. So just quickly, I will go through the some works that we're doing at the National Sustainable Robotics Center, which is established in 2021, and it was mainly designed to scale up the research we are developing at the university to higher TRLs, and it's especially designed for robotic disassembly. So you can see some of the works, especially for battery disassembly using the heavy-duty arms and custom design tools and sensors we have over there. So to wrap up my presentation, I wanted to thank my researchers at the Extreme Robotic Lab, University of Birmingham. You can see later some of our medias and some works actually on our YouTube channel, or you can follow me on LinkedIn. And that brings us to the end of my presentation. Again, thank you all for listening to my presentation. I believe we have a few minutes left for any questions. Thank you.
Yes, thank you very much, Ali. So yeah, questions. There is one in the chat. What do you feel is the biggest area of challenge with your work?
Yeah, so as Chung mentioned, actually, it very depends on the application. So we are working directly on the industrial challenge for battery disassembly. And the main challenge of using telerobotics in industry, and especially for battery disassembly, is designing actually right tools for the end effector during disassembly. So we already covered how we can actually use master slave efficiently, and this is not a new technique. Actually, for many years, this technique is used in nuclear industry. However, having the right tools, right grippers, in addition, actually, the work that we carried out related to developing various types of interfaces, we found that it's really useful. We started with direct viewing of the scene, just normal camera views, and later we enhanced actually the user capabilities using various types of mixed reality platforms, point clouds, and using virtual reality, augmented reality. So we feel that for not continuously, but for some tedious tasks, sensitive tasks, it's very useful to use these kind of teleoperation systems. But at the same time, it has some drawbacks, actually. Continuous usage of virtual reality, especially, is reducing actually the performance of the user, and also the task performance will be not good if we actually use these kind of virtual reality headsets continuously. So to summarize, actually, having right interface and right tools for teleoperation systems would be great, actually, to investigate it further.
Thank you, Ali. We have a couple more questions. I'll pick one of them, which I think is quite relevant. Where do you see the line between telerobotics and automation? Does one fit the other, for instance?
Sorry, could you please repeat the question again?
Where do you see the line between telerobotics and automation? Does one feed the other?
All right, that's an interesting question. So, again, as I mentioned, actually, we based on my experience, we can't use telerobotics for all applications, and we are trying actually to, in the process of especially industrial applications, we are trying actually to make autonomous systems that robots can complete the task without human in the loop. However, there are some tasks that should be handled by human, and in that sense, actually, for some tasks we need to have human in the loop. And I think that there is a direct link between automation and telerobotics in that sense.
Okay, thank you very much, Ali. I think there's a few more questions in the chat. If you could maybe answer them, that would be great. And we'll have to crack on with our agenda. But thank you very much for your presentation, and Chang, again, thank you for yours. I think it gives a really good flavor of different applications and different challenges with telerobotics. So yeah, we have still quite a lot of time. I will go through a few of the more, let's say, organizational topic group updates, and then I'll hand over to Daniel to get some more input from you, from our audience, because we'll start one of our road mapping sessions. So in terms of the topic group updates, some of you know there was a mailing list migration earlier this year. If you're not getting any emails from the mailing list, or if you are never signed up for the mailing list, please get in touch with one of the co-chairs of the group, so myself, Alois, or Daniel, and we'll add you to the mailing list. We are planning to run seminars such as this one every quarter. One of them will be reserved for European Robotics Forum workshop in March. But if you would like to present your use case, your industrial challenge, your application, your products, or state of your research at one of the webinars, please get in touch with us as well. Another update for the incoming months, the Spark portal, which was used as the main place of the topic group information capture, that as probably many of you has been quite difficult to navigate through, will be made obsolete soon, and will be transferring to the new portal based on the Open Social platform. And I think that should be live in the new year. But you will get the updates through the mailing list. So again, if you're not on the mailing list or not getting anything, please let us know. In terms of European Robotics Forum, as probably or hopefully most of you know, it's next year in March in Rimini in Italy. Like every year, our topic group proposed a workshop. Next year workshop will be covered under the title of Telerobotics and Teleoperation, Solving Cross-Sector Challenges. And we'll have a few keynotes from representatives from space, infrastructure, nuclear, and healthcare. And we'll follow up that with in-person roundtable discussion on the challenges of transferring technology across sectors. And the last and probably the most important update is road mapping. So that's been building up for quite some time, but till the end of this year, we'll have a couple of activities focusing on creating a roadmap for the various topic groups that will feed into the e-robotics roadmap and new e-robotics strategy. And yeah, hopefully we'll start that in a few minutes. And if you have any questions about the topic group, please put them in chat, or please contact us directly on the email addresses that I left in the chat above. And now I'll hand over to Daniel, who will lead the road mapping and strategy part of the workshop.
All right. I would share my screen for that because we were asked to fill a form. So can you see the screen and hear me?
Yeah.
Yes.
So the task that we have is to identify challenges and trends, I think, in the first place for the different areas, the different topic groups that we are within e-robotics. And for that, the e-robotics was setting up a mirror board, which is what you can see over here, for all of the topic groups. So we do have already filled out, which is kind of like a thing that I just want to show you, information filled, for example, in the industrial robotics topic group. There's also a well-filled exercise already done for, where was it? Let me just have a quick look. Who else filled something already? There was a meeting here. There's a good example of sustainability. So the sustainability topics group, you can see them over here. They sorted things already. The final idea is to consolidate 5-ish challenges and work them out later on. So for that, I already started our Telerobotics and Teleoperation mirror board over here. And I took the liberty to just take the insights from the 2 presentations that we heard and group them here by color. So with the first presentation here being in orange and the second presentation here being in green, and some common challenges with respect to the application domains in blue over here. So there is probably the possibility for everybody to log in. If you do not have a login, it's not a problem. You can just drop in your brainstorming information into the chat. And I guess the logged in people or the coaches can pick them up and we design the workspace over here. As we are now currently only collecting the brainstorming information, you then can just dump your ideas into the chat and we will push them up. It's about the key challenges. So what do you think are the key challenges? Later on, we will consolidate them and then work them out more detailed. So there's questions like, what did we gain if we solve the challenge? What are the main difficulties in solving the challenge? And why should we even invest in solving this challenge? And then from that, there's also a second board that you may already want to fill with information, such as the key trends for the topic group involving technology trends, market trends, but also framework conditions, all of them being sorted by the 3 tier L levels. And also here, I took the freedom to place a few bullets already, a few of these sticky notes down here. You can just grab them, pull them up, enter a text, and that's it. So it's as easy as that. Control set is a bit buggy, it appears, but it shouldn't be a problem. So just grab your sticky notes and bring them over, or as I said, push them information into the chat. And then at some point, there's also a request to fill in projects of Telerobotics. So if you have a project that is currently running, send us this information as well, put a link into the chat, and we will fill this information here as well. So that's about it. So that's our task. So I'm also now looking into the chat if I can find it. There's information already. This answers put here. So, but just let me know if you have any input. So what do you think are the biggest challenges in telerobotics and teleoperation right now? Just, you can also speak up if you want to. I think it's fine. We do have like 36 people attending still. Now I collected the 2D interfaces, the limitations of them, the challenge to create immersive telepresence in general, creating interactive digital twins, that's something probably, and then the use of telepresence as a co-pilot for automation. Yes, that's a good one. The network infrastructure, visual effects, comms, latency. I'll just put that, I don't know which one, over here. There we go. Perfect. Yeah, that's the same thing, I guess. Optimized communication challenge. So how do you optimize them? Yeah, that's basically probably also related to the task. So we can do things like that. Link them closer. There's a project. Let's do that quickly like that. Sometimes it's a bit funny, the thing. No. All right. Just like that. We will clean that up later on, but that's already good input. Latency. Yeah, there we go. Things are filling in. Oops. Aspects in teleoperation. Yeah. Situational awareness here. That works really good. Heterogeneous robots. Yes, totally agree.
Yeah, I think that's one of the big barriers, really. most of the more mature stuff is built for one application or one use case. It would be good to have, some kind of toolbox like you have with some of the industrial robotics applications where you can build them fairly quickly. Having something like that for teleop, where you can build your solution out of, fairly mature building blocks, rather everything from scratch, how it usually happens.
Yeah. Mark, maybe you could specify what you mean for safety data for autonomy.
Yeah, I'm just thinking about, but I work in the nuclear industry. And so for us, if we're going to be using robots to do tasks autonomously, the confidence that it's going to do the right thing, it's going to do it safely, it's going to move where we think it's going to move, is all going to come under a whole lot of scrutiny. And it's coming from an industry that thinks you can only rely on hardwired systems. So we don't like software safety systems. They're not accepted at the minute. I think that's going to change, well, at least in the medium term. So yeah, just having information on how reliable the autonomous system is. Yeah, that's all I'm getting at.
All right. Thank you very much. I just added it. We're getting there. Yeah, we are. This is like this is really cool. So maybe what about applications? So I just grabbed a few domains. So what are other domains? Who's working which domain?
Kang brought up agriculture earlier, which is, I think, quite interesting.
Healthcare. Yeah.
So healthcare, space, nuclear, usual suspects, military still.
Infusion, right. Speed of operation in general. Okay, that looks pretty cool. So I tried to group them as I was collecting the information. So there's like communication channels and things like that, networking stuff, and then data and information about that. And then there's some human factors over here, along with a bit of like things like cost and regulations. So maybe all the human related things over there. Then I have something that is about AI-enabled things and maybe also a bit of the technology. I think maybe we can split that up here. So there's a lot of haptics and so on. And then there was the one from obviously the first presentation that's coming out over here. But maybe we can also maybe we can also try to consolidate them now. Like what would be the 5 or more or less challenges that we want to better dive into, that we want to describe into more detail? I'll take the last comment here, but if you have additional comments, just let me know. What do you think are the dimensions that we should try to consolidate along?
Like I can see couple of groups here. One is, I think, definitely around telepresence, all the immersive side of things, but also human side of things.
Cost is a big one. How do we reduce cost, right? How do we
yes?
Yeah,
but I think cost is also connected to something that's popping up here about modularity, interoperability. and that side of things. Because again, cost is high because everything is bespoke for the certain use case very often.
Yeah, but what you can do is like now, and that's the thing, right? So cost is a challenge, and it is defined by things like now this is the time to move things over, right? Cost is defined by modularity. So if we do not have modularity would allow us to solve that, and maybe you can even push it over here. What are the main difficulties in solving the challenge? So how can we solve cost, make it things modular, but modular systems are difficult to create, right? So then we could also have like safety could be a one for itself, right? Cost, safety. Latency is probably another one that we figure.
Yeah, latency and reliability in general.
Second one you said, what was it?
Reliability.
Reliability?
Yeah.
And latency comes with communication challenges, I guess. And in general, I think safety was one that we could take up. Would you put safety and latency and reliability next to each other or as one point? Or maybe we can do it like that.
Not necessarily safe to evolve. I mean, they're overlapping in a way.
Mm-hmm.
But both will have, different reasons. Safety will have a lot of regulatory aspects and industry-specific aspects, like with nuclear or healthcare, where latency reliability is more technical, I would say.
So Eloise also proposes to have modularity as a dimension.
Yeah, I think so. It affects the cost, but it's not the only paradigm, the cost.
I mean, we can have different the different application domains, we could have them as one thing. So essentially, that. So we have all the domains. There's a suggestion to add situational awareness. Different viewpoints here. The haptics probably is part of the awareness, convincing haptics. I'll take Joao your entire comment, I think, and just put it next to situational awareness. There's also these here. Which could be put here, I guess. The 2D interfaces do not help if it comes to situational awareness. Generally the immersion and digital twins help as well, I guess. Can also later on move these then to the right-hand side if you think. Or Eloise, I think having AI actually is as an own challenge is probably something that we may want to address. It has to do with so many things, right? So we will have safety regulations and so on and so forth. So maybe we can try to do that somehow.
Sure.
Maybe we can just, all right. So maybe we can just have the, the domains somehow separate. So they are somehow additionally here there, but. So, but then again, I think I want to put this one up because I don't want to have AI on the top.
Nice.
Let's deal with safety first. So there we go. Working architectures. And then the autonomy based on the level of of the network and so on. And that's going to come over here. What about the humans? Human aspects and the impact on human versus teleop use?
I mean, that comment from Joao earlier, that it should we cover situational awareness as a broader human factors aspect, because it doesn't cover only the technical side.
Which one do you mean?
If Carol's saying that, what Joao was saying as well, and it could make sense if we make situational awareness, that current challenge, more broad, something like human factors.
Okay.
It's just, I think then we have lots of challenges inside that.
Yeah.
Let's see. It's getting big here, right? So.
But I mean, we can always split it up later. It's for the moment, I think as long as we have all the ideas down, it's good.
More things over here. Regulations. What about regulations?
Maybe safety.
Oh, that makes sense. The modularity seems to be a bit on the smaller side. Maybe maybe it's about cost. I don't know.
Mm-hmm.
Let's check what do we have here. That's kind of cool. That's like having the AI, like use telepresence as a co-pilot for automation. I think this is like adding to AI because you're teaching a system. I'll put it here. Long duration use. I think that's like maybe human factors. Oh, gee. Speed of operation. Is that something with respect to the reliability, I think? Heterogeneous robots, maybe this has something to do with modularity, I think. That's cool. Multiple robots, modularity, also on the side of the, like on the event side.
Yeah, I agree.
There's a lack of high frame rate that comes over here. Standardization, maybe with respect to safety. In control modalities, maybe also about modularity, right? Modular input. So that's the other side of the system. Hardware.
Could also be modularity.
I think so, right? Standardized data sets, messages. I feel that maybe we should have this as a standardization efforts here instead of safety somehow. What do you think? Or should be
maybe to be discussed. They're related, but still separate.
Yeah. What about that one?
Safety or human factors? Maybe safety. I'm not sure. I mean, the others have ideas.
Right. I think that is okay-ish. It looks like something. This is still, we can still move around things a bit. The one. Modularity or cost? I think maybe modularity is a good idea. The domains. It's also from related, it's explicitly telling machine learning applications. I think maybe we can put it in between here. Like that. All right. Cool. That's cool. Looking at the time, we have like 8 minutes. How should we progress? Eloise and Carol, maybe.
I think we should have at least one another session cover the rest of this table and start the next one. And yeah, I think we can share the Miro board here. We did the same thing for industrial robotics, so people can add their thoughts in the meantime, or just digest what's on the board, and we can continue at the during the other session.
So, Carol, maybe we can email the Miro board to all the member groups.
Yeah, I think that's the best
to all
way
the members.
Let's send the link to the mailing list.
And then, do you have the link? Can we put it also on the chat in case there's
I'm
those
just doing it now.
Oh,
yeah.
Thank you.
Great.
It's good effort. That's the most challenging part, really.
Yeah, I think maybe in some of the people that are really willing to help here, they are welcome to fill the form right further to the right hand side, and then I think it's probably worthwhile to schedule at least one more meeting for this one, right? For the trends, and if you have any project that you would like to be highlighted here, so just let us know. There's a project list we need to fix. Right, with that, I would give back to Carol, I think.
Yeah, I mean, we will be wrapping up, but yeah, thank you very much for attendance. I hope that it was informative and that the session was useful to you. If you want to leave any feedback, you're very welcome to hear it, because that was the first one, and we're planning to do more. If you want to present at the future seminars again, just get in touch with us, and probably through the mailing list again. If you're not on it, just leave us your details, or drop us an email. We'll be letting you know about the next session probably in the next couple of weeks. I guess we might pick a date tomorrow, and we'll send you more details by the end of this week through the mailing list. Yeah, thank you very much. Again, thank you very much, Ali, and I think Chang is still here. Thank you very much for the presentations. I hope it was quite useful for you guys as well. And you will hear more details through the mailing list. I'm not sure when we'll try to do the next one. We have ERF in March. December is probably not the best time. Maybe we'll try to do something in January, but we need to have a think. Again, thank you very much all, and I have a list of emails to add, which is good. Thank you very much. Have a great rest of the day, and let's keep in touch. You will be hearing more from us through the mailing list.